Assalamualaikum warahmatullahi wabarakatuh to Dr. Noida binti Muhammad. Today, me and my group member will presenting about a DfMA project about water heater shower. So before that, I would like to introduce my group member. So firstly, me is Muhammad Manur Hamri Bedul Malik, and my group member is Muhammad Muhaimin bin Yahya, Muhammad Adam Buhari bin Hamidun, and Nur Fadila binti Muhammad Fazil. Alright, so I would like to present about our background of studies. So basically, design and assemble DfMA is mainly the method for determining the component design and also the overall evaluation of assemble design. And the method used is efficient way to identify the problem and can redundance the parts in assemble, and also can be calculating total assemble time and the cost. Alright, so for our project, we decided for our objective is to disassemble the water heater shower into a singular part for evaluation. And second is to evaluate the assemble efficiency for original and redesigning the product. And third is compare the assemble efficiency of original and redesigned product in terms of assemble time and assemble cost. So for our scope is the DfMA manual worksheet used for evaluation of the original product and redesigning the product. And lastly is to redesigning the product in this study only theoretical, and there are no prototype will be produced for this study. This is our problem statement in our project. So so we can see the task given for our lecture is to design the product so that the cost and the times for production can be lowest and maximally. So we choose the product is water heater shower, and the method used for analysis is DfMA manual worksheet. And the part quantity for the water heater, we choose it only 30 parts, and the category for the water heater is the bedroom parts category. So that's all for me. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum and good morning. My name is Muhammad Muhaimin, and I would like to present the literature review and the methodology. First is the literature review. The first journal title is the Design for Manufacturing and Assembly Component Level. The finding of this journal is the DfMA for single component is discussed in the chapters of components design, and the focus for this chapter is the product level. This is written by Jerry Wang, the Mechanical Design for Electronics Product, DfMA and Failure Analysis. Next journal is the Design and Manufacture Assembly. The findings for the journal is the individual parts and components made by various manufacturing process are assembled into finished products by different method. This was found in the computer-aided manufacturing. The third journal was the overall impact of the DfMA on industry, written by Geoffrey Boyd-Hurt, Peter Dewhurst, Winston, from the Product Design for Manufacture and Assembly 3rd edition. The finding is the preceding case study describe a few of the successes resulting from the application of design for manufacturing and assembly software. Then is the design for manufacture and assembly in construction, written by Sang-gyeon from Design for Manufacture and Assembly in Construction. The findings is design for manufacturing and assembly is known as both a philosophy and methodology whereby products are designed in a way that is amenable as possible for downstream manufacturing and assembly. Last journal is the title is the Electric Water Heater for Shower, written by Rex Youngas from Electric Water Heater Shower. He stated that the heater has various provisions which severally and in combination improve, protect it from overheating and burnout under all operating conditions, and it for shower use with maximum safety. Okay, next is the methodology. Here we can see the flowchart for this project. First of all, start where we get the product of water heater shower from our lecturer, the product that we need to interpret the method of design for manufacturing assembly, and then we define the from the product we can define the project objectives and the problem statement. We study the product to relate with the design for manufacturing and assembly. We can also do the scope for the project and the significance of the study, and then from the product we deassemble the every part and component of the product and do a classification for each parts and component. We deassemble the product one by one, and we from there we take the dimensions, which include the length, the width, the height and the thickness for every part and component. From there we can do the assembly process evaluation, which is the manual Booth-Royd-Dewhurst method. This method is to find the product, the part of the product efficiency. First of all, we need to do a table of design for assembly, and then we refer to the table of part insertion difficulties and part handling method. From there we can find the operation cost and operation time of the part, and then we can do an estimation if the part can be improved or modified. Then when we done with the table of design for the assembly, we can do the part modification and improvement. We also can eliminate them or simplify the part, and then the re-evaluation of the modified parts. We do a re-evaluation of the modified parts to find if the new efficiency, the new design that we find after we do the modification, and then we do a result comparison from the old design and the new design, which part is better in terms of efficiency, operation cost and operation time. And then we do the calculation and recommendation, and then we got the last result. Next is the step and procedure for this method. Like I said before, first we disassemble the product and do a classification for each parts and component, and then we assemble the process evaluation using Booth-Royd-Dewhurst method, and then we do the part and component modification and description, and then we do the re-evaluation of modified parts using Booth-Royd-Dewhurst method with the new part modification and improvement. Lastly, we do the comparison result from the original and the new design of the product. That's all for me. Thank you.
Assalamualaikum. My name is Muhammad Adam Bukhari. For the analysis of the old product, as you can see, there are total of 30 parts. Each part are characterized by their manual handling and insertion properties according to the table provided for the manual analysis of the DfMA. Okay, from the table we can calculate the operation time of the product, and then we calculate the operation cost, and lastly we will estimate the candidate for the elimination parts. Okay, next is the analysis of the redesigned product. As for the redesigned product, there are total of 22 parts. The redesigned product has less part compared to the old product. As you can see, each part of the redesigned product has been characterized by their manual handling and manual insertion properties from the table provided. Okay, and then we calculate the operation time and operation cost of each part of the redesigned product in order to determine the design efficiency of the redesigned product. Okay, from the analysis of the old product and the new redesigned product, there are a few possible improvements that can be made. First is eliminate the fastener such as screw washer, nut and clipper instead of fastener. Build a casing with a snap fit mechanism. Next is build a spring with a built-in stopper in order to reduce the cost and operation time. As we know, less part will lead to less cost and operation time. As for the switch handle, part ID 1, we change the material from PVC to LDPE plastic because it is more flexible and softened at 70 degrees Celsius. Number 4, change the square shape of the button, part ID 12, into some other interesting shape. As for the pump stopper, part 27, change the material in order to enhance its strength. Next is change the design of the front cover by adding a holder for a better grip. As for the push button, change the design into a round shape for easy assembly. As for the comparison of the old design and new design, we can compare from the number of time the operation is carried out consecutively. The old design has a higher number of time the operation is carried out consecutively, while the new design has lower number of time the operation is carried out consecutively. Next is the old design has a higher operation time in second, while the new design has lower operation time. Old design also has a higher operation cost, while the new design has lower operation cost. The old design has a design efficiency of 0.26, while the new design has a design efficiency of 0.45. Old design has a higher number of parts or components. New design has a lower number of parts or components. This comparison can also be made. There are many comparisons that can be made, but we only managed to compare for 5 of the characteristics between the different of the characteristics between the old design and the new design.
Hi, I am Nur Farahila binti Muhammad Fazil. I'm going to present the discussion for this project. Based on the result and analysis, there are many improvements that can be done towards the product of water heater shower with the help of Design for Manufacturing and Assembly DfMA. Using the method of manual Boothroyd Dewhurst, an analysis can be done for each and every part of the product. There are about more than 30 parts of water heater shower. Every part plays their own role for the product. But once we disassemble the product, we realize that there are some part of the product can be modified and improved. There are also a part that might be eliminated or replaced. That is why Boothroyd Dewhurst method was introduced, especially for the world of engineering to improve product from old design into new design. There is specific software for analyzing product using Boothroyd Dewhurst method. But for this project, the method was done manually with the help of part handling and part insertion difficulties table. These tables is for references for the manual method of Boothroyd Dewhurst. But first, a table of design for assembly DFA must be made. This table must be filled with the part description that mainly to find the operation time and operation cost. Based on the part handling and insertion difficulties table, we can find value of the part, thus the operation time and cost. An estimation of theoretical minimum number of the part also can be identified. With all 30 parts of the water heater shower, we can estimate and determine the part if it is needed to eliminate or simplify based on the table of DfA that had been done. With all the data collected, we can find the efficiency of the design product, which the formula is 3 times the total value of estimated minimum number of parts divided by total value of operation time. The higher the number of efficiency, the better the product design. As observed, the number of efficiency of the old design is lower than the number of the new design. This shows that the new design of improvement from the old design is high in efficiency. In other words, the old design is better than the new design, which means the new design is a success. The product includes a lot of fastener like screw, nut and clipper. Some parts can eliminate these fastener and replace them with a cover that has snap latch or snap fit mechanism. Thus, the part number can be reduced and the product assembly is much more easier. At the same time, the operation time and cost can be reduced. A modification of a part also can be made, like changing the shape design of the shower head for a better grip and low friction when handling. Other than that, some material of a part can be changed, like the switch handle from PVC to LDPE plastic for better flexibility and softens at 70 degrees Celsius. With all these changes of improvement and modification, a higher number of efficiency can be obtained, so as the product design is better. As the conclusion for this project, the DfMA analysis can help us to improve our product, which is water heater shower, in many aspects by disassemble the old product. By doing this project, we can achieve better efficiency in redesign the new product with 0.45 efficiency compared to the old design, which is 0.26 of efficiency. This is proven as there is a reduction in the number of parts and assembly time on the product being studied. The improvement for the assembly time required seems to reach almost 50%. It means that 2 products can be completely assembled compared to 1 product for the original design. Therefore, this would allow the production line to increase the number of output for 1 day. Other than that, the total cost for the redesigned product also shows a huge improvement. The total cost for the redesigned product is 53 ringgit and 20 cent compared to the original design, which is 100 ringgit and 64 cent. Thus, it shows that the redesigned product can save up almost 50% from the old design, which they can be seen as profitable. For the recommendation in this study, there are few recommendations can be applied for future research as to improve the water heater shower. The recommendations are as follow. First, the methodology preparing the DfMA analysis for water heater shower can be changed to the automated way, which is by using the software to avoid any mistakes in calculating and so on. Second, avoid human error as possible as you can, such as misread the data from the table provided. That's all. Thank you.